Welcome to the Bio and Beyond podcast. I'm your host, Sawik Nath, and today we're diving into the world of biomedical engineering. Please join me in welcoming our distinguished guest, Dianne Babski. She is the Director of User Services and Collection Division at the U.S. National Library of Medicine. She is responsible for managing one of NLM's largest divisions and oversees budget, facilities, administration, and operations, including a national network of more than 8,000 academic, health science, public libraries, and community organizations to improve access to quality health information. Ms. Babski serves as the Scientific Review Administrator on the Literature Selection Technical Review Committee, a federal advisory committee responsible for recommending journals for inclusion to MEDLINE. She currently leads a Gen AI pilot at NLM, which leverages the latest in Gen AI to unlock new pathways of biomedical discovery, increase operational efficiencies, and achieve better user experiences across NLM resources. Without further delay, let's dive right in. So why don't you tell us a little bit about yourself?
So great. Yeah. So again, I'm Dianne Babski. I'm the director of the National Library of Medicine's User Services and Collection Division. And my background is in biology and information management. And those two marry together very effectively to allow me to support all of the products and services across the library's portfolio of products and resources. I started out in biology with an intention of curing the common cold. And I worked for one semester in a lab with fruit flies, and I decided that lab work was not the life for me. What I really got involved in was the data behind it and recognizing the need for well-structured and well-formatted data so that you can use it across different research ventures. I think I got into public service because, well, I started out in the military way back. And again, I did a lot of work in the behavioral sciences field in the Army. And from there, I got into doing additional research also in behavioral sciences. I went on to work across at NASA and another institute at the NIH. And again, I found what my passion really was in data management and information management, and really being able to provide good data, normalized data, because when you do that, you just open up the opportunities for repurposing that and making it useful in so many different ways. I ended up here at the National Library of Medicine when I was working at the National Institute of Allergies and Infectious Disease, and the API that I was working on broke, and I called over to the National Library of Medicine to complain about it. And they said, hey, we have a job open, and, you might be interested in working on something like this. I applied to the position, I got it, and I've been at the library since 2005. And I love it here. I love the passion. I love the work, and I love our mission. So I am here to stay.
That's really interesting how you complaining about something ended up in you getting the job. That's actually a pretty funny story.
It is pretty funny. It is, yes.
Uh, well, that's really interesting. So, could you share us an example of a successful initiative or project that has significantly improved access to health information?
Yeah, it's really hard to pinpoint any one project or initiative. All of the products here at the National Library of Medicine lead to significant improvements to health access and health information for a wide variety of users, including patients, consumers, librarians, health information professionals, clinicians, policymakers, media. Our literature products like PubMed and PubMed Central open the door to discovery. We have our whole portfolio of genome, proteins, genetic products, that help with understanding and relating to basic sciences. Consumer products like Medline Plus and Medline Plus in Espanol provide easy to read access to information. And we provide access to organized and semantically structured vocabularies and terminologies like MESH, our medical subject headings, health data standards like SNOMED CT, which is a clinical vocabulary, RX norm, which is used for naming drugs, and LOINC for medical tests and observations. I thought it might be helpful for us to, for me to also tell you about a couple of key things that just came out, because I'm excited about them. And so these are some new shiny toys out there. So we've just recently launched a new Center for Clinical Observation and Investigations. And of course, there's an acronym with it. We're in the government. So it's called CCOI. And it's a groundbreaking center that's going to allow researchers to test their hypothesis and on data found in large-scale clinical databases. So we're going to provide access to a lot of clinical data and allow that to be used to drive discoveries as well. We also recently launched the NIH Comparative Genome Resource, again, an acronym CGR. And that's a platform that helps researchers compare genetic information of different species, which is really cool. If you haven't gone in and tried that, I highly suggest it because you can really look at the genomes together, and it makes it visually more appealing. So this resource is used to better understand how genes influence health, disease, and evolution by studying the similarities and the differences, of course, in the DNA of various organisms. We also just launched the dataset catalog, which I like to call the PubMed of datasets, and it will help users to discover and access a wide range of biomedically oriented public datasets. The Food Pathogen Project is, I think, a groundbreaking initiative. It's not new, but in case people don't realize that it's something that we've done. So this initiative collects and analyzes genetic information from harmful bacteria and other pathogens found in food. And this helps scientists track foodborne outbreaks and understand how these pathogens spread. So it's really helping to identify wherever there's an outbreak to identify it locally and find out where that source is coming from. Really cool stuff. And later this month, we're going to be launching a new product called Women's Health Discovery Portal. So we're partnering with the Office of Research on Women's Health to support the effort to develop we're calling this a one-stop shop for anyone to find NIH research, literature, data terminologies, and everything related to women's health topics. So it's a really cool platform that is really going to change some of the way that we work. So instead of having to go to 7 different systems to get what you want, we'll provide it in a one-stop shop. So it's a nice foundational product for us to move more into. The other thing that I want to emphasize is that, and I hope you understand this, is that we're not just a library, but we're also a huge research organization. And we have 2 major areas that we focus on, which is computational health research and computational biology research. And as you can see, many of the findings that I've just talked about come from the work that is done in that part of our organization.
From the way you talk about all of these, I can tell that this is definitely your passion. You're very interested in this. So,
Yes.
which one of these initiatives would you say is your favorite? I know that you're passionate about all of them, but which one would you say is your favorite?
I couldn't pick a favorite. Each one of them is special because they have a different focus or a different, stakeholder interest. So data set catalog, again, that is a passion of mine because I'm always trying to get people to find the data from research, repurpose it, and not duplicate efforts. So for now, I'm just going to raise my hand for the data set catalog because I think it will really help to inspire new research in new ways, because you can look at what somebody's already done and build from that. Tomorrow might be a different answer though.
So I know that you are leading a Gen AI pilot at NLM. So could you explain what this pilot involves and what you hope to achieve with it?
Yeah, so this is I am sponsoring this project, and it's, again, I'm very passionate about it and I love it. It's been a 6 long month large language model pilot, um, which which NLM staff, I had some of my staff come to me and say, hey, I really want to get involved with Gen AI. I want to support innovation. I want to support curiosity. So I figured out how we could get into that and do it in a safe and secure environment. So we have a Strides account through NIH that does provide access to AWS, the Google services, and of course the Microsoft Azure environment. And those are behind a firewall for us. So the objectives of this pilot were to test these large language models for the benefit of some of our internal process improvement. We do a lot of curation of data. So most of the data that we get is from outside sources, and we have to reformat it. We add a lot of additional access points to it. So anything we can do to make that go faster and automate it is a win in my book. Several of our pilot projects were oriented around that, and improving our curation efforts. So improving processes, we also wanted to develop workforce skills, and really work in a collaborative way in a community of practice type environment. So we pulled people from different divisions to work across and share what they do, the products that they work on, and how Gen AI could solve some of their problems. We also applied the NIST, the National Institute of Standards and Technology's AI framework. We use that as a guideline to ensure that what we're doing with artificial intelligence is done in a trustworthy and responsible and ethical way, which is, it is a government mandate as well. This also represents a culture of innovation project. We do have everyone here at the National Library of Medicine is passionate, and everyone enjoys, implementing new things. So really supporting this culture of innovation is important to me as a manager and a supervisor and as a leader in this organization. So what we're doing is we for all 10, it was a 10 use case pilot project. We created proof of concepts for all 10 of them that worked. They worked effectively, mostly using RAG, to our own materials to answer questions. We're now in the next stage where we're taking those proof of concepts and moving those into MVPs, minimal viable products, and then we'll test that further and put these algorithms into production and into operation in our products and services.
That's really interesting. So for a bit, when you were talking, you started talking about the community. So could you tell us a little bit more about how the community at NLM is?
So we have so it's actually grown from that. So we started with our pilot in our own organization at NLM, and recognizing that everyone at NIH was interested in using Gen AI in some capacity. Me and another person at our computer information technology, our Center for Information Technology, CIT, Nick Weber is his name. He and I joined up together to co-chair an entire NIH community of practice for Gen AI. So this expanded from my small 10 use case pilot to now we have monthly meetings, and this was done by word of mouth, and we have over 600 people involved in that community, and really about 200 to 300 show up at every meeting, and we share what we're doing. We're talking about how we're implementing this. We're working in the same environments, and we're bringing in outside organizations to tell us, what are you doing and how can we work together? So it's really just spun into a much broader community, and I think it's led to a lot of great engagements that we otherwise wouldn't have been open to.
Yeah, that sounds really crazy. Having a community that big all working together for one goal. That's really interesting.
It really is.
Yeah. So, what are some of the most exciting developments you've seen so far in the use of Gen AI in biomedical discovery?
So I think it's too soon to say they're there. I think most of what we're doing with Gen AI is experimental, and the jury is still out on it. I think that testing it, even using something like the NIST framework, is a little sketchy because, as you can put a prompt in today and get an answer. You can even prompt 2 minutes later and get a new answer. So, the jury is still out on the consistency of it. And that's something that we really want to make sure that we're following because, again, we provide health information, and we certainly don't want to put anything out there that is, um, fraudulent, fake, or, a hallucinogen. So some of the things that we're putting out there is, I think you've heard of Trial GPT.
Mhm.
Trial GPT is a novel use for using LLMs because it takes the information from patient notes and electronic health records, um, uses the criteria for getting into a clinical trial, and maps potential patients with open clinical trials. So this is really important because clinical trials are really essential for advancing medical science and improving public health because they test the safety and potential side effects of new treatments, medications, and medical devices. So being able to test these things is really essential, and you need participants for that. So this is a great result because if we could, from electronic health records, flag patients that could be potential candidates, I think that will be a great use of this tool. A few other things that I can see, just because of the speed of it and the possibility, um, using massive amounts of data, I see a lot of benefit coming into data summarization, being able to draw conclusions that maybe we just can't think about because it can just really process it in that capacity. Um, Customer service. There are many use cases across NIH, including ARPA-H, that are really looking into how can we answer patient questions in a safe and reliable way. And so that to me is a huge use case and something going on in many parts of NIH. And again, like I said, ARPA-H, they're testing how to actually implement and test any kind of patient interfaces that can go on. The other thing I think that has really great potential is drug discovery. Just thinking about chemical structures and possibilities, thinking outside the box of our own human limitations, I think will actually really be very, very beneficial for that. Imagine the possibilities if you're not confined to only what can be possible, but allowing the system and the data behind it to generate new things and new possibilities. So chemical possibilities and the increase of drug discovery, I think is going to be a huge development coming forward. Clinical applications in so many ways. I know we funded one project where this organization was creating these automated cameras to watch patients, and clinicians and practitioners respond to patients to focus on where they have to. So through this camera applications, it would flag things, and so it really reduced nursing and other clinical burdens because you focused on where the AI generated that flag for attention. So very cool possibilities with that. But also, just thinking about some other patient care points, you know, tracking and providing information to patients, between appointments and visits, better imaging assessments. Again, I think looking at imaging is going to be huge because, again, the beautiful thing with AI is that it can look around the corners and fill in the blanks and do predictions. Whereas, when we're looking at it, it's like, it has to be round and orange to be an orange, whereas, AI can do much better predicting. Faster recognition of epidemiological events through surveillance and risk factor predictors, I think also is another thing to look at. What is the vaccination status in different populations? I think making connections between real world impact and research. So again, I think there's a lot of potential for lay people, high school kids, anyone to use these tools, get access to a lot of information, and really think outside the box to make new discoveries or think about new things in novel ways. Thinking about novel connections through semantic searching, I think that's another big place to go. And just the ability to challenge large data sets, provide summaries, and look for things. I know we're looking at another project at NIH is looking at our funding portfolio and saying, what have we funded? What's the gap in there? Where are some new things to focus our energies? And again, it's just hard for us to craft those questions and to look at the data that way. Whereas and artificial intelligence algorithms can really look behind the scenes and come up with new things that maybe we wouldn't think about. So I think there's a lot of potential going on with that.
I agree. Even in the early stages, the potential that Gen AI could have in the next couple of years is pretty crazy.
It is,
Yeah.
definitely.
And adding on that, how do you see the role of NLM evolving in the next couple of years?
Yeah. So it's interesting because 2036, which is not too far away, will be our 200th anniversary. And our mission is to collect, preserve, and disseminate the biomedical literature and biomedical information. That is going to continue to be our legislative mandate. I see NLM is going to be setting the stage to be the data hub of biomedical data and information in a global capacity. I see us playing a crucial role in integrating diverse biomedical data sources, making them more accessible to researchers, clinicians, the public, commercial entities. And this includes improving interoperability of health information systems and expanding access to large scale data sets. We already do a lot of that, but I can really see us ramping it up to more connecting the dots. We're already pioneering and leveraging AI and machine technologies in much of our research and soon, hopefully, in our everyday production and processing. I see that as being able to free up some capacity of our staff. If you don't have to do this type of work, what can you do? Because we can automate a lot of our processes. And again, in the research piece of this, I see us as being a key player in promoting research, again, clinical imaging, and making discoveries and really summarizing data to help share what we're finding. We'll likely play a huge role in training the next gen of biomedical informaticians, data scientists, health information professionals. That is one of our mission strategic plan goals, is to develop a workforce. And we'll continue to refine, develop, and deploy tools that support biomedical discovery with a goal of improving the public's health. So one thing I want to end with is our newly appointed NIH director, Dr. Monica Bertagnolli, expressed her vision for making NLM a, quote, revitalized hub for biomedical and research use and sharing. She emphasized the importance of integrating scientific research with public health and clinical care to inform new research and improve health outcomes. So in this vision, She sees the library as serving as an interactive and productive leader with the international community of biomedical data science organizations, working to provide stability and functionality of the broader biomedical data ecosystem. Again, think interoperability. She sees us as a point of providing a front door where biomedical or clinical research domains, trainees, patients, advocates, anyone has a front door and a one-stop shop to accessing information. Any of the tools, and being able to grab data to repurpose it as well. She sees us as maintaining an open and scalable federated digital ecosystem for access to biomedical data and the analytics behind it, and an epicenter for NIH-funded research, which will advance information science, analytics, data science, and really promote biomedical discoveries. And of course, another key piece that I just mentioned is to provide educational programs to equitably expand biomedical informatics, data science capabilities, and our research workforce.
Well, it looks like the future of NLM is looking pretty bright.
It is.
So before we end, I have one last question. What advice would you give to someone interested in a career in health sciences information management?
Yes. I have a list here, so let me point out some of the strong ones, and I'm going to end in a plug for our products for one of our programs. So my thing is to start networking. That whole adage of it's not what you know, but who you know, definitely true. Join professional organizations, attend meetings, conferences. You really have to get in the know with other people. Gain skills in research, including data design, modeling, and curation. Be aware of data evaluation and synthesis techniques and how users want and need the information. Don't just say this works for me, really look at the data and make evidence-based decisions on what you're doing. Stay on top of emerging technologies and digital tools. Again, those conferences, meetings, learn from other people. There's tons of blogs and podcasts and all kinds of tools out there. So, those you can do while you're walking or driving and learn at the same time. Embrace failure as a learning strategy. I know often it's hard, especially in the public service environment. We want to protect what we're doing, but failure is a great learning strategy. And not taking unpredicted risk, but being risky in what you're doing really does promote discovery. And recognizing that being a health professional is evolving. You got to be agile with how you work, where you work, when you work. You have to embrace those technological solutions and different technology as it comes up. And the last thing is you got to stay curious. If curiosity is not your thing, I would encourage, I don't even know how to train that. It maybe not be a trainable thing, but just ask questions, talk to people, and engage to be curious. And again, my last thing that I really want to push here is we have a training programs at NLM, and I would consider anyone that's interested to apply to our intramural research training program. And it has really great opportunities for high school students, undergrad students, and of course, pre and postdocs as well. So there's lots of opportunities at lots of different stages in a career, and we really want to help set the stage and the foundation here.
Well, that's really interesting. And before we end, do you have anything else you would like to add?
No, I'm just really excited. I'm happy to participate in your podcast today. And if anyone has any questions, reach out to me. I can be found on the NIH site. Just look me up, Dianne Babski, and always happy to talk and tell you more about what's going on at the library or across NIH if I can.
Okay, well, as we wrap up this fascinating episode, I'd like to thank Ms. Babski again for sharing her incredible knowledge and expertise in technology and its application on medicine. We'll continue these captivating conversations at the intersection of science and innovation. Until next time, this is Satwik Nath signing off from the Bio and Beyond podcast. Remember, the exploration of science never ends. There's always more to discover.